You drop an ice cube into your glass of water, and like magic, it floats. Simple, right? But if you stop and think about it, that's not normal. Most solids are heavier than their liquid forms and sink. So why does ice float on water? The answer reveals one of the most unusual and life-saving properties in all of science. To understand this, we need to zoom into the molecular level. Water is made up of tiny molecules, 2 hydrogen atoms and 1 oxygen atom, H2O. In liquid water, these molecules are constantly moving, sliding past each other, packed closely together. But as water cools and begins to freeze, something strange happens. As water turns to ice, its molecules rearrange into a special structure, a crystal lattice. This structure holds the molecules further apart than when they were in liquid form. So even though the molecules are the same, they take up more space. This increase in volume makes ice less dense than liquid water. And according to the laws of physics, less dense things float in more dense substances. That's why your ice cube stays on top of your drink instead of sinking to the bottom. It's not because it's lighter in weight, but because it's lighter in density. To see this in action in real life, think about a frozen lake. In winter, the top of the lake freezes into a layer of ice, while the water beneath remains liquid. This floating ice insulates the water below, protecting fish and aquatic life from freezing. If ice sank, lakes would freeze solid from the bottom up, killing almost all underwater life. But because of this rare property, life under the ice can continue, even in freezing temperatures. This same principle keeps your cold drink from getting too warm too fast. Floating ice melts slowly, keeping your beverage cool while staying at the top where it absorbs the most heat. That's useful design, powered by science. Right pointing finger emoji, if you're enjoying how even a simple ice cube can lead to big scientific ideas, hit like and subscribe to this channel. There's a lot more science hiding in everyday things. Now let's talk about why this knowledge matters beyond drinks and lakes. Understanding why ice floats helps scientists study climate change, especially in polar regions. Melting sea ice doesn't raise sea levels because it's already floating, but melting land ice, like glaciers, does. This knowledge helps us model environmental impacts accurately. In engineering, ice's lower density is used in designing ice-breaking ships, cold storage systems, and even survival strategies in extreme climates. In chemistry, it explains water's unique expansion when freezing, a property not shared by most other substances. In daily life, this concept is used in food science, ice cream making, drink cooling, and even weather forecasting. And for students, understanding why ice floats introduces them to core physics concepts like density, molecular structure, volume, and states of matter. It also highlights just how special water is. It's the only known substance that expands when it freezes, and that one fact is why life exists in many parts of the world today. Imagine Earth without this property: frozen oceans, dead lakes, lifeless winters. A floating ice cube, it turns out, is a small reminder of nature's brilliant design. So, the next time you sip a cold lemonade, glance at the frozen lake, or watch frost form, remember, ice floats not by chance, but because of a very rare exception in the world of physics. And that exception helps make life possible.